Hey guys, I'm just about to launch my leebenson.com blog, and I thought I might give Ghost a shot, which is a node-based blogging platform. And what might make a quite a fitting first post is to introduce Docker and Docker Compose and show you how I use those to orchestrate a Ghost blog. Now, the quickest way to get Ghost running locally is actually just to use the public Docker Hub images of Ghost. I'm using Kitematic on my Mac, which is installed along with Docker Toolkit. And once you've downloaded that and you've hit create, you can see within the space of just a few seconds the thing spawns, and we can click web preview, and there we go, we've got a Ghost blog. The problem with this approach is that it hides the details. You don't really know what's going on beneath the hood. And so what I prefer to do where possible is to build from source and build my own private or public Docker Hub repos, so that I get a finer control of what's going on. In doing so, hopefully I can impart some concepts of Docker and Docker Compose, so you can use that as a foundation to orchestrate your own services going forward. So with that in mind, let's go ahead and build this thing locally. So I'm going to be using WebStorm as my IDE of choice, but if you want to follow along, feel free to use anything. I'm going to call this blog. I'm just going to create an empty project, and the first thing I'm going to do is download the Ghost source. So you just download Ghost into a browser, hopefully get a direct link, save some time, and download the zip file. Go ahead and extract that. Now in the old days, we've got the source tree here. Probably what we'd do is edit the config file manually, then maybe we'd FTP over to the server, tweak it, hope for the best, a few different rounds of back and forth, and we'd finally get the thing working. In today's environment, it's much easier to use something like Docker. For those that don't know, Docker is a containerization platform, so basically allows you to bundle up all of your build steps and all of the software that your app needs into one or multiple containers that are guaranteed to run exactly the same way regardless of the host platform that they're running on. Docker works on Windows, on Mac, on Linux. It works natively on Linux, on Windows, and on Mac. It requires a virtualized environment, but Docker have made that quite a streamlined process for those environments, so you can just download the toolkit and pretty much everything is taken care of for you. So let me grab this stuff and throw it over into a WebStorm folder. Now what we're going to be using in this is something called Docker Compose, which takes Docker a step further, and it allows you to chain together multiple containers and treat them as one individual app. In this case, we're going to be using MySQL as the data store, and we're going to use Ghost as the main container that's going to link to it. So we've got our content there. First thing we're going to do is create a file called .docker ignore. You can think of this as a git ignore file. It's just going to tell Docker what to exclude from the Docker build context, what's going to be invisible to Docker. A couple of things I'm going to put in there. The first thing is called idea, which is just a folder that WebStorm installs with a bunch of settings. And the next thing is node modules. This is really just defense against possibly using that folder in future. If we were to install something from npm locally, it's going to compile everything and throw it in node modules. We don't need that. That's a redundant step because Docker is going to build that for us as part of a build step. And also it's possible if I'm on a Mac and I'm using this in Docker, which is targeting a Linux platform, that I'm compiling things that are only going to work on Darwin. We want to target instead a Linux build. So let's just leave that alone. Let's leave it out of the context. Then I'm going to go ahead and specify the Dockerfile. And this can be thought of as a make file. It's going to provide all our build instructions. The first instruction is what we're building from. We need a source image to extend. So I'm going to say from node 4.2. And where do we get this from? Well, we can just go over to hub.docker.com, and there's thousands of images that we can pull from. So node is one of them. We've got an official node package there, and you can see a whole bunch of tags. In this case, Ghost requires the 4.2 branch. That's one of the official targeted platforms of Ghost. Whereas if we were to open my terminal and type node-v, we can see that locally I'm running 5.1. So another benefit of Docker is that you get to isolate versions without cluttering up your main file system or trying to figure out how to run multiple versions of the same software. So next step is we're going to create a directive called work dir or work directory, and this just specifies the context that we're going to run all commands that follow within. So it's basically going to run everything from an app folder on our Docker container, and if I was to run any command or install it, it will do so within this directory. Next directive is a command called copy, and I'm going to give it this context, which is the build context, which is by default the current directory. So I'm just going to say a single dot, and then the context of where we want to install it, which is going to be here. So this work.dir. So because I'm already in this folder, I'm just going to give it a dot also. Next command is a run command, and I'm going to run npm i --production, which is going to install everything from package.json, everything that Ghost needs to run. Now we've got a couple of directives that expose different parts of this Docker container. So by default, a Docker container will run isolated from everything else. So we have to specify if we want any ports opening or if we want any mount points within the file system opening. So first thing for a port, I'm going to expose 2368, which is the default Ghost port. That's what the Ghost web server is going to run, and you can go to config and you can see that there. We could change that to whatever we want, but in this case let's just leave it as at the default, so we have to change as little as possible. And the next thing we're going to give is a volume directive, and what volume allows us to do is to specify a mount point. So you can think of a mount point as the ability to persist data when we're next running Docker. So by default, when we run a Docker container, any change we make within the file system disappears and resets back to its build context or its build version the next time that you run it. By giving a volume directive, we're saying, hey look, the data within this is its own volume, and if you want to map that locally to a mount point on your own file system on the Docker host outside of the container, you can do so that the next time you run that, it's going to use that same directory path and mount it there so that you've got access to that same data. It's going to allow you to persist data, in other words. Final directive is cmd, or command, and this is going to be the default command that runs in the absence of any other command. We can override this with our own, and we'll do so in a moment just to test this functionality, but if we don't have any other command, this is what's going to be run by default. In this case, this is just going to run index.js, which is going to start our Ghost server. So that's actually enough to go ahead and in these 10 lines of code to spawn the Docker build process and run a Docker container. So let's first of all go ahead and check that out. So I'm going to close the terminal actually. I'm going to go to Kitematic, and you see Docker CLI provides a shortcut to open a terminal window and set all of the environment variables it needs to run Docker. So it's going to set the Docker host and the Docker file path and all that type of stuff. So if I type Docker images, you can see a list of images that have been downloaded so far. I've got MySQL Server 5.7. I've got Ghost from an early step when I showed you spawning that. I've also got Node 4.2. Now I've downloaded these in advance just to save some time, because these are about 400 or 500 megabytes each. Some of these are even higher in some cases. But you don't actually need to do this in advance. Just by giving the need in our Dockerfile and in our future Docker Compose file, it will download that stuff as and when needed. So don't worry about that step. So now what we want to do is we want to navigate to our WebStorm projects and blog, and I'm just going to say Docker build, and I'm going to give that a tag of test. That's going to overwrite this previous test tag that I had before. If nothing exists, it will create it, and I'm going to give it the current directory context and hit enter. And you'll see, because nothing has changed from a previous build the last time I run this thing, it builds it ultra fast. Now if we were running this the first time, what would happen is it would of course run the npm and it would download all of the npm packages and things like that, but we've managed to skip that step, and so for the sake of this video, let's just go ahead and run this immediately. So now that we've built it, running it is just a few millisecond affair. It's very, very quick, and what we type to run it is Docker followed by run. I'm going to give it two flags. I'm going to give it I and T. I stands for interactive, basically allows us to use the keyboard and interact with the application, and T is terminal. It's going to start its own shell, and I'm going to give it the test build file name that I gave it before, which is the repository name. At this point, we could give it a colon and a tag, so maybe latest or version 1 or something like that. But we didn't specify any tags, so we can't use that. This is just going to be a plain tag. And I'm now going to give it the command that we want to run. Now, if I didn't give it any command, just hit enter, it will go ahead and run the default command, which is actually exactly what we want in this case, node index.js. But if we do give it a command, like bash, let's say, which is going to start a terminal shell. Sorry, let me just enter that after the name of the repo there. You'll see within the space of maybe half a second, a quarter of a second even, we have a bash prompt into the container. So we can run anything locally. We can run ls just to get a directory listing, for example. We can edit any of the source. But remember, once we exit out of this, because we don't have any persistence to this data, it's going to be lost the next time. So let's just demo that just to show you. So if we echo hello to something called message.txt, you can see we can print that out to the screen, and we can ls that, list that, and it's right there under message.txt. But if we to exit and then run the same thing again, you'll see this time it's disappeared. So although we've got our volume directive, we haven't actually mapped that to any other path. And actually that's in content anyway, so that's not going to touch our app folder at all. We'd have to give that as another context, another volume directive, if we wanted to mount our app path elsewhere. So we've got what we need for Ghost, but now we're going to use Docker Compose to create another container. This one's going to be MySQL, and we're going to get the two talking to one another. So what I'm going to do here is just go to new and create a new file, and we're going to call this docker-compose.yaml. It's going to be a YAML file, so it's going to use that configuration. And we're going to specify Ghost, which is going to be the name of the image that we've just created. This is an arbitrary name. We can call it whatever we want, and it in fact can point to a third-party image, or it could be local to the build context. So I'm going to show you both of those ways in just a moment. So for Ghost, first thing we're going to do is give it a container name, and I'm also going to call this Ghost. And container name is just sort of the prefix that's used in things like environment variables. So other related or linked containers are going to use this name to know which other container to map to. I'm also going to specify a build context. In this case, we're building from our current directory, so we're just going to use a single dot there to note that this is the current directory. And we're also going to map the ports. So you'll recall from our Dockerfile that we've already exposed port 2368, but we want to map that to the Docker host. And in fact, to make it easier, rather than having to type 2368 in a web browser in order to access Ghost, let's map it to the main or de facto port of HTTP, which is port 80. So what I'm going to say here is that's going to be port 80 that it gets mapped to, and it's going to point to the local port, which is 2368 of this particular container. I'm also going to set an environment variable, and this is just going to be node env of production, and this is just something that Ghost uses in order to run this particular configuration block up here, the production block. Okay, cool. So we've got everything we need just on those few lines in order to spawn Ghost, but we want to link it to MySQL. So let's create something up here called MySQL, and the container name is also going to be MySQL. And this time it's going to be an image, because we're going to be pulling from the public Docker repo. We already have it locally, so it's going to just use the local cache, but if we didn't have it, it would actually pull from MySQL server, and we'll be pulling from here. So we're just going to give some parameters in order to start up a MySQL server. So the path for that is MySQL/MySQL server, and I'm going to use colon to give a version, which is going to be 5.7. Again, I like to be very granular with the versioning. So with the likes of Ghost, we need Node 4.2, that's fine. But also we don't just want to use the latest tag here, because MySQL could launch version 6 or something that completely breaks the current context or the current build process. So what we want is to specify a very specific version and test it against that, so we know in production it's always going to work against that version. So environment, let's give a few different variables there. I'm going to use the MySQL random root password, because we don't really care about the root password here. We would obviously in production, but this is just a test environment, so we don't care what root password it spawns. I'm also going to specify a database. Let's just call that Ghost. Same thing with user. We don't really care about building a secure environment here for a couple of reasons. Number one, we're only using this in a test environment. If this was in production, we'd make sure these credentials were very, very secure. But also, we're only creating a secure tunnel to Ghost. We're not actually exposing this publicly. So we've got an extra layer of security there as well, which we don't rely on, but it's nice to have. We're also going to give a volumes directive, or a volume key there. And what this is going to do is just going to create a mount point on the default MySQL data directory, so that when we're creating our settings and we're editing things in the admin control panel and adding posts and things like that, it's not going to disappear the next time we start the server. Okay, so at the moment we have two containers, but they're disparate and detached. They don't know of each other. So the way to link them is just to use a links key. And down here we're just going to say links MySQL. So what this is telling Docker to do is to first spawn MySQL before it spawns Ghost, and then provide all of the environment variables that this publicly exposes into Ghost, so that we know how to set Ghost to talk to MySQL. So we've got our secure tunnel, but what we need to do at this point is we need to tell Ghost, the application itself, how to speak to MySQL. So at this point I'm going to go back to config.example.js, which is where we specify all of that stuff. And you'll see the first thing I need to change is URL. My Ghost blog doesn't mean anything, doesn't point anywhere. So I want to see what my local machine is. So I'm going to use something called Docker machine. I'm on the ls command. And that's basically going to show me the IP address of where my local Docker host is running from. Now obviously in production, or if I was running this as a real blog, I would put my domain name in there. But in this case, this is just a privately addressable Docker host. And the client at the moment is using SQLite 3, which uses a local file path in order to store the data. But we actually want to get it to talk to MySQL. So at this point, I'm just going to type MySQL. And there's a few different connection parameters there that we're going to add as well. Now, obviously, instead of a file name, things that matter are host. I think we need a user. We need a password, we need a database name, and we probably need a character set so it knows how to speak the language. So that's just going to be UTF-8 by default. So where does it get this stuff from? Well, these are environment variables that are fed into our Docker build. So they're available OS-wide. So we can actually use process.env, which is an object that Node has by default, which pulls from the process, the OS environment variables, and we have access to all of those. So we can actually refer to the documentation and see which variables Docker as well as MySQL offer by default, or we could go into Kitematic and we can actually spawn the MySQL server, and we could look at those variables as well, but I'll just type them from memory. And the first one's going to be MySQL port 3306 TCP ADDR. Now this is quite a standard format, and the format that Docker follows is basically the name of the service followed by port, followed by the port that it by default runs on or exposes. In this case it's 3306, which is the default MySQL port, followed by the protocol, which is TCP, followed by the address. You don't have to remember that, it's available in the documentation. User is, let me see, it's MySQL env. So this is just the same thing, but it's an environment variable. It's available within this particular YAML file. So it's going to be this stuff. So anything that exists after this is available under this branch, MySQL env. So we've got MySQL user, and then here we're going to have pretty much the same thing but with password instead. And same deal, but with the database. I think those match up. Password, database, and user. Yep, we're good to go. And at the moment, we're binding to port IP 127.0.0.1, which is the local loop interface. We don't want that. We want to bind it to all available IP interfaces, which is then going to include Docker as a host. So we'll specify all the zeros there. And the port is fine. We're exposing that through here and through the Dockerfile. So we're good to go. So with those configuration changes and the Docker Compose file, I'll just give that one quick glance over. It looks to be good. So I'm going to go back to the terminal and see which directory you're in. We're in the right directory. I'm going to type Docker Compose, then up, and that should create MySQL, create Ghost, and spawn the entire thing. Now you'll see we've got a problem, connection refused. So let's figure out what the issue is there. I think that's because it was already running before. We'll start that again. Yep, good to go. Okay, so if we go into Kitematic, you'll see we've got both of our containers running now. We can click on this little cog next to IP and ports just to get an idea of what's running. We can see general environment variables. We can go to volumes. At this point, we can actually change this and map this to a local volume. So MySQL is being stored outside of the container. Even on a container that's connected to the file system that the Docker host is running on. In this case, it's running sort of a virtualized environment within the Docker host. It's still going to persist our data, but it's doing so within the Docker host, and we've also got Ghost. If we click here, we can see a little Ghost preview, and we're good to go. At this point, we can type /ghost, spell this properly, and we can go ahead and create our account. And I'll do this just in order to show the persistence. So we should see this thing running. Take me to my blog. Now, of course, there's going to be a bunch of things that you'll need to do on top of this in order to get it running in production. One of those things is to configure the email service and things like that. But we won't do anything that's beyond the scope of this video. Instead, I'll just create test post. Say this is a giant test. And I will just go ahead and publish now. And if we go to our blog, we'll see that this thing's working and everything's working well. Well, what happens if we exit out of this thing and we respawn it again? So you go back to Kitematic, you can see that the containers have now closed. I'm going to use Docker Compose up. And it's going to start the thing again. If I hit refresh, you'll see that the post is still there. And the reason for that is because the data has persisted. So hopefully that gives you an introduction to using Docker, and specifically Docker Compose, to string together multiple containers. And now that the thing's up and running, we could run in any environment that has Docker installed. So any Linux or Windows environment, we just go ahead and install Docker. And along with this Docker Compose YAML file, we could literally just install that one file, copy that one file over, and type Docker Compose up, and that's all that would be needed in order to run this entire thing. Assuming, of course, that we've bundled up our build processes into images that are publicly accessible on hub.docker.com. It's the same concept. If you're running a private repo, you just need to use the Docker login command. So that's just Docker login, and specify your username and password and things like that in order to log into the private repo. But it's the exact same concept. That one command alone will spawn however many containers you have. I've had different build environments where I'm running 10 or 15 different containers, a whole bunch of different things that are orchestrated and have private tunnels working between them. It's a really nice way to get things running without having to resort to the old-fashioned way of FTPing files over, or the middle ground of having to create virtual machines and copy over entire operating systems. This is a much cleaner, slimmer way of doing that.